The most important part of working in a lab is having your safety gear, which includes a lab jacket, safety glasses, and of course gloves to protect your hands. The first step of the extraction process is to clean and bake these 200 milliliter amber vials. We bake them at 450 degrees Celsius for about 24 hours, and then we clean them each 3 times with methanol, hexane, and acetone. Once you have your amber vials baked and cleaned, the next step of the process is to handle your PEs. It's important not to physically touch your PE as much as possible to avoid contamination. So what we do is we use metal clamps, and we clean the clamps again with methanol, acetone, and your solvent to keep it clean and avoid contamination. Lots of times in the field, as the PE is out in the field, the PE can get very dirty, especially in the water. So to avoid contamination inside of the gas chromatographer and mass spectrometer, it's important to wipe down the PEs to get as much residue off as possible. After completely submerging the polyethylene sheet in its solvent, it's important to next add an internal standard. An internal standard is a mixture of deuterated and labeled compounds that are representative of the analytes of interest over relevant molecular weights. Adding an internal standard gives us an idea of how well the extraction goes after concentration. After the internal spike is added, it's important to cover the lid of the amber vial with tin foil to avoid as much evaporation loss as possible while extracting, and to seal it tight with a lid. Afterwards, the PE is ready to begin extracting and must be placed in either a box or some kind of drawer where sunlight cannot affect it, because the sunlight can hinder the extraction process. For 24 hours, the extraction has taken place, and the next step of the process is to concentrate to prepare for analysis by mass spectrometry and gas chromatography. The PE is carefully taken out of the extraction vessel, trying to get as least amount of solvent out of the vessel as possible. Since the molecular weights of the solvents are relatively low, they evaporate very quickly. The PE is laid out to dry. Afterwards, the mass of the PE is taken, and everything that we are measuring is inside of this vessel. The solvent is then transferred into a turbovap tube, which is used to, a turbovap is used to concentrate the solvent down to a smaller volume. In order to make sure there is a quantitative transfer of analyte of interest, The extravasant vessel is rinsed 3 times with your solvent and transferred into the turbovap tube. Now that your solvent is inside of the turbovap tube, it's ready to be concentrated down to about 0.8 milliliters. This is a turbovap where a nitrogen line comes from our tank inside of the turbovap, where it is blown over the solvent, and there's a water bath that evaporates, that is heated, which evaporates the solvent off, which concentrates the solution. By setting the turbovap to about 30 degrees Celsius and having the nitrogen flow over your samples, they're concentrated down. By carefully monitoring the volume of your samples, when the samples are about 0.8 milliliters, a little bit below 1 milliliter, they're ready to be taken out of the turbovap. However, in order to get it analyzed by gas chromatography and mass spectrometry, there needs to be a further concentration. Because we don't want to concentrate the volume down too fast with the turbovap, what we use is a mini-vap. Since we can't concentrate the samples any further inside the turbovap tubes, what we do is we transfer the sample into a smaller 2 milliliter amber vial, which can be concentrated further down with the mini-vap. Similar to before, we want to ensure quantitative transfer from the turbovap to the 2 milliliter amber vial, so we rinse the turbovap tube 3 times with solvent and transfer it into the 2 milliliter amber vial. Now that the sample is transferred into the 2 milliliter amber vial, it's ready to be concentrated further by mini-vapping. The mini-vap is usually connected to the same nitrogen gas line, where nitrogen flows through these tubes into the 2 milliliter amber vial, where the volume of the sample inside the 2 milliliter amber vial is slowly concentrated to about 0.2 milliliters. After the mini-vap is finishing concentrating the sample down to about 0.2 milliliters, the sample can be taken from the mini-vap and capped in order for the sample to not lose any more of the solvent. Now that the sample is concentrated down to a volume that can be used to analyze in gas chromatography and mass spectrometry, the sample is transferred into a small glass vial insert. It's transferred into the insert so that the gas chromatographer and mass spectrometer will easily be able to access the sample when taking the analysis. Right before analysis is important to add an injection standard into your sample. The injection standard is a labeled compound representative of the analyte, which is used as a reference to the instrument to measure the compounds at a specific peak height. Again, in order to ensure quantitative transfer, the 2 milliliter vial where the sample is concentrated by mini-vapping is rinsed 3 times with solvent and transferred into the 2 milliliter vial with the glass insert. After transferring quantitatively into the glass insert, the sample can be capped and is ready for analysis by GCMS.